Okay. Um, Hello. So what I wanted to talk about today is I wanted to explain how and why I connected my rover, which is wonderful wandering growth, to the internet. So first I'm going to present my goals, and I freely admit a lot of them are hindsight. Then I'm going to give you the tool chain that I'm using, and most of it Eric is using as well, simply because we have the same hardware. I want to talk about the potential portability to other Yak rovers. I want to get feedback and hopefully also get a volunteer who volunteers to allow us to try extending this tool chain to their rover. Okay, so what did I figure out was my philosophy? First of all, instead of failing fast and often, I wanted to actually succeed fast and often, even if the successes are small, because otherwise I might lose, momentum. So whenever I had a choice between digging deep into a problem and finding a quick and dirty solution which appeared to work, I would do the second one. Um, Second concept is making the whole process interactive, and but not the type of interactive which means that a user could control it using a joystick, but rather the type of interactive where I can replace parts of what the human is doing with various types of automation. It was very important to have portability to other platforms, and which means that in whatever I'm doing, I'm leaving room for a layer which will act as an adapter, a matching layer between what I have and somebody else's rover, whatever it might be. Now, I consider this to be a prototype. In prototypes, you're going to throw one away, which means that if I can ignore something, I'm ignoring it. Reliability is definitely not the most important thing. And I try to avoid committing to a specific tool set, meaning if I can replace one of these components, and I think most of them can be replaced, I want to leave that option open. Last but not least, in the spirit of Yak Rover, I want to be able to publish what I'm doing, and I want to be able to work in public so other people can follow me if they want to. Okay, so what did I want? First of all, I wanted remote access, which means that you don't have to be next to the robot in order to control it. Regarding control itself, I decided I do not want real-time control. It's not that I can't do it, I don't want it. Real-time control is very addictive, but it interferes with making the system autonomous. I want to use commands, and one of the reasons I want to use commands is because in a future time, I would replace the entity giving the commands with some sort of artificial intelligence. I want the rover to be programmable from remote, not only controllable from remote. And to the extent possible, I want it to be serverless. Now, obviously, the rover connects to servers, but I don't want to have to maintain my own servers. I don't want the rover to be tied into some base station which provides services. Another thing I wanted was the possibility for the public to have access. Right now, we have access, but not security. I want to have documentation of what we're doing. And I want a slow and thoughtful rover, perhaps like Perseverance, and not a fast and agile one. Okay, one last background slide. The work as a member of the Yak Collective is obviously very fragmented, which means I want whatever I'm building to be modular and incremental. So when I pick it up, I can do something, and then when I'm done, I can put it down and pick it up a week or two later and still works. And that really meant that I'd be working in layers. When I had a choice between buying something, and by buying, I mean using a free tool, of course, or making it myself, I decided that even though it was more fun to make things, in this particular case, unless it had to do with the core issue of what a rover is, I would buy it. I decided that the work I'd be doing would be partly a vehicle for exploring the available tool sets, which means that I'd be very happy to try out a tool set, and if it doesn't work, replacing it. Whatever I'm doing, I know it's going to be a test bed for exploring part of the robotic control space, and that affects design decisions. And I also know that it's going to be some sort of test bed for adding sensors and actuators, though I haven't yet. And that also affects the architectures that I'm using. So are there any questions about this background philosophy or no? Okay. Now the hardware requirements are very important. And the ideal is they should be as minimal as possible. Otherwise, I'm not going to get portability. So one requirement is video input. Though, of course, you can make a rover without it, but it seems to be less fun. Some sort of movement actuator, which makes a rover go from place to place. And as you'll see, I don't commit to using legs, even though I am using legs. I need to have an onboard Linux board with Wi-Fi and some reasonable amount of storage. And I'm assuming that for interaction with sensors, I will probably have some sort of separate real-time hardware. Right now, we actually have that. Okay, so what you see now on the screen is the complete tool set that's used for connecting the rover to the world, and also a little bit for the rover functionality. But I'm not going into the rover functionality today, except as it relates to connecting outside. So I'm assuming you're familiar with all of these tools. If not, very briefly, Linux is an operating system. I'm using it for glue. Python is a programming language. I'm using it to do programming and control. GitHub gives you support for managing software. I'm using Discord, which is a chat app for a text user interface. I'm using Twilio to support video streaming on the internet. I'm using Twitter in order to provide a social user interface for the rover. I'm using Google Drive in order to get large amounts of data in and out. And for myself, I'm using VNC or a direct connection, a screen or a keyboard, in order to interact personally with the rover. Okay, this in general is tools that I'm using. And like I said, each one of these components could be replaced with a different component, but perhaps you'll see why I chose them. So we'll start with Linux. one of the big advantages in having a rover which is Linux-based rather than one which is based on Arduino or some other hardware-type board, is that Linux has a wonderful set of tools, and they're all very useful. The first tool I'm using is Bash scripting, or shell scripting in general, and I use it to tie together my different modules. If you remember, one of the design goals was to have it modular so I can pick it up and put it down. One of the ways to do that is to program in one language and have some other tool put together the pieces. It's also very convenient for managing settings. All of the keys to the various tools, file locations, the name of the rover, and so on. Linux also has a boot sequence, meaning when you turn it on, it does certain things in a certain order. And of course, we want to do that. Linux has external tools, which we need, for example, for video. And it also has internal tools like cron. If you want the rover to send out a message on social media or check its status, you can write the software. And last week we heard about the super loop and things like that. But if you have an operating system, you don't have to worry about that. In addition, Linux has a nice range of interfaces to hardware. In this case, V4L2 is an interface to video and cameras. And an important point is that Linux is not strictly real-time. In other words, it doesn't respond in microseconds to interrupts, at least not in a reliable manner. But for my type of slow and thoughtful robot, it is real-time enough. And like I said, the advantages of having it manage everything are very, very significant. The second tool is Python. I'm using Python 3. Python is a general purpose scripting language. It is very flexible. It's readable. It has a very easy on-ramp, meaning it's easy to write simple programs, but it also has a very powerful set of features, at least powerful for what we're doing with the rover. It has many, many, many libraries. So all of the tools that I showed you, Twitter has multiple libraries. Discord has a library. Every tool you can imagine, somebody wrote some sort of Python interface wrapping that allows you very easy integration between Python and that tool. It comes with Unix, with Linux. It is not fast. In other words, when you run something in Python, it's going to be slow. And it's not going to be memory efficient. But if you really, really need to, you can link what you're doing to compiled languages, and those parts can be faster, more efficient, more memory efficient, and so on. Now, why is this a problem? It's a problem because at some point you run out of memory and you run out of CPU. But for test bedding, I think this is good enough. Next tool is GitHub. Now, GitHub is basically used for deploying software. I have to get whatever software I write onto the rover. And the easiest thing to do is to use GitHub. Git is native to Linux. So again, it works together naturally. There's still some settings like keys and so on that you have to do manually, but to the most extent, the setup is via GitHub. GitHub also allows you to automatically perform actions after you deploy software, and you can use that to finish the deployment and integration steps. It allows me to develop the software on a different computer, which is what I do. And that's especially important because the rover has a power time limit problem, which we've talked about in the past. From the other side, GitHub supports sharing. It means I can share the development with other people. I can share the software with other people. I can work in public so people can track what I'm doing. And it also allows people, including myself, to add issues and track them. So for informational purposes, the two main repositories we have now are IMZ1 and Rover Twitter. IMZ1 is most of the interface, and Rover Twitter is what has to do with Twitter. Discord. So Discord is a chat system, and what's nice about it is it provides a chat interface which is equally usable by humans and by computers. In fact, computers can do a little bit more. But for argument's sake, whatever a user can interface, a computer can interface. That makes it very convenient when I want to move from interactive to, let's call it AI interactive, with some automated systems doing, the interaction. It has a good library for building software. I don't need a separate server in order for people to discover the robot. You just log into Discord, and if you know where to log in, you'll be able to access the robot. It provides all of the issue of connecting through firewalls and address translations. If you have Discord running, the rover is able to connect, and I can ignore all of that. It also provides supportive file transfer, and I use that in order to program the rover. In other words, you can upload a program to the rover using Discord. It's one way of giving public access and control. It's also a way of working in public. All of you have seen demonstrations of the rover where I used Twitter, where I used Discord, and you could see what other people were doing. You could see what the rover was doing, and so on. And the way it's set up is that we have a bot written in Python executing on the rover, listening in on the Discord server. Okay, so I said serverless. In a sense, the rover itself is a server for Discord. Now, Discord is a little bit complicated, so I think it's useful to give a few more details about what I'm doing and why I'm doing. So first of all, when you create a bot in Discord, you create it with your ID. But the bot gets its own individual ID as if it was a Discord user. Like any Discord user, it's not really part of Discord until you add it to a server. Now, I added it to two servers. One is a Yak Collective server, and one is a private server that I use for development. So the same rover can listen on multiple servers, and perhaps you want to distinguish. The rover can identify which server it's connected to and act accordingly. So on one server, it will give you more access. On a different server, it will give you less access. You can also use this for access control and so on. Discord bot has permissions for Discord, just like a human being has. Channels it can see, channels it can't see, types of messages it can send, and so on. And the rover itself, the Discord bot acts exactly like a human being. Meaning whatever human being could see, the bot can see, and whatever human being could not see, the bot cannot see. So the main way in which the bot works is it gets a message saying an event called message, meaning somebody sent a message. Of course, the bot can also detect other things like reactions, users joining, changes in names, messages being deleted. Now, all of these things that a human being, if you were looking very, very carefully at Discord, would be able to see. But for my purposes, the main event we care about is message. You send a message to the rover sends a message back. The libraries, which allow you to add another level of abstraction to the different commands. Perhaps I'll show you. Just a second. So here's an example of the code for IMZ1, which is a Discord bot. And what I want to show you is the level of abstraction. You have events in general that you can detect. Already means that the rover has managed to connect to Discord. And here's a command. The command is called test. It has a help message, and it has a Python function that runs when you do it. And here's another command. It's called upload. And when you run it, it uploads an attached file, and so on. Okay, so if you want to add another command to the rover, it's as easy as adding one of these functions. The bot that I wrote, as you can see, is written in Python. And when it gets a command to execute, it either runs Python code, which directly controls the rover, or it calls a bash script, which controls the rover. Now, let me give you an example of why I want to do that. Let's say I have a command that makes a rover walk forward one step. Now, I might want to access the command using Python through the Discord server, but I might also want to access the command using a Twitter command, and I might also want to access it using some other tool, which I can't imagine now. So I have a separate program which moves the rover forward, and the user interface just activates that program. Now, usually I activate the program indirectly using a script. And the reason is that by using a script, it's very easy to add glue for publishing more information or getting more user input while carrying out the command. Twilio. Twilio is a service which allows you to do many things having to do with communication. They give you telephone numbers, they do SMSs, they do voice communication, but they also do video. Basically, what I'm doing is I'm building a video room. And it really only takes just a few minutes to get Twilio to work on your browser. I know because I tried it. And it took me a few weeks to get it to work on the rover. There's all sorts of fidgety settings. It had to run on the Raspberry Pi. It had to use a non-standard camera. It had to run headless, which is difficult to debug. It had to run one-sided. I could go on. However, the support staff was very, very helpful. They were, in fact, proactive. sending me ideas out of the blue of what to try. In any case, Twilio gives a stable, high-quality connection. It has automatic reconnection. It knows how to generate video rooms on demand. It has multiple options. It's not very expensive money-wise, about, I think, 0.18 cents a minute, some other small number. But video can be intensive, and using it uses up about 10% of my CPU, and I'm not sure how much of my memory. And we need this memory for image processing, which right now we're not doing much of, but we will be.
Meir, that was, you remember the workshop you've done last time? That was Twilio that you were using, right? For us to see the video in our browsers.
Right.
And so it looked like the board was just working fine. I mean, despite the CPU cost and the memory cost.
Yeah. Well, first of all, it's a demo.
Right.
I was taught how to give demos, even if I don't always show it. But more important, the bot wasn't doing a lot of onboard image processing. For example, if the bot would have been trying to do onboard
Object detection,
stereo image analysis,
Hmm.
okay, it couldn't do it in real time anymore. So this side of it is not solved yet, but one of the reasons for choosing this architecture is I believe if tomorrow I had to move to a different board, let's say the Jetson, it wouldn't be a problem. And if I wanted to offload some type of processing, that also wouldn't be a problem.
All right. Thank you.
Okay, so a few more details about Twilio. First, you need a user. When I joined, we got $15 free to experiment. I haven't yet used it all up. Okay, like I said, it's cheap. The video streaming is provided basically as a one-sided video room. In other words, only one side can send video and audio. I don't send audio. And that side is a rover. So the rover sends video, and if you join the room, you can watch that video. The course depends on the number of connections, which means there's some code to make sure that the room gets disconnected as soon as there's nothing to see. You can have what's called an ad hoc video room, which means the minute somebody joins, the room is created. Or you can have an actual named room. Most important, I think, is the peer-to-peer option. When you use Twilio, you have two ways of working. One way is you send your video to a central server, and that central server distributes the video to all the clients, like what we're doing now in Zoom. The other way is peer-to-peer, where the video is sent directly from the rover to all of the clients. Now, if you only have one client, that's not a problem. If you try to put in multiple clients, or you try to do local recording, that quickly uses up the CPU.
So how does this work? Like, is it just sending via some TCP streams or UDP? How I didn't understand what's happening here.
I can answer you. In other words, it's using a WebRTC.
Okay.
But it doesn't matter to me. In other words, Twilio is only one of several packages that you can find which allow you to quickly build video conferencing inside a browser. So from my perspective, what I have is a JavaScript library that I run in a browser, and this JavaScript library knows how to connect to my webcam, And it also knows how to send video out on the internet in a way that a client that somebody else wrote knows how to connect the video stream and shows a video. Okay, this is an example of the buy versus make decision. Okay, sending video out using RTC, you know, that could be interesting. But what was more interesting is being quickly able to set up a system where people can use standard, well-known tools and, like I said, replaceable tools in order to tap into the video stream. The tricky part, like I said, is setting up headless Chrome in such a way that it will allow me to create video tracks and will be able to detect the camera and will stream the video.
Headless Chrome, that's just a browser that's running on the rover, and from the point of view of a service like Twilio, they actually don't know the difference that it's a rover as opposed to a human producing a video feed from a laptop. Is that the sort of abstraction there?
Yes and no. First of all, the rover is a laptop. In other words, we could be having this Zoom call through the rover and nobody would know. It has a Linux-based computer with a webcam, and that's it. By headless Chrome, what we mean is that in order to conserve CPU, I'm not running any of the display engine on the rover. So Twilio doesn't care who it gets a video stream from, but the JavaScript that comes with Twilio expects for you to be using a regular browser. So what I have to do is I have to tell the browser, don't show me a video, don't show me anything, but yes, connect to a webcam, yes, send it out, and that's it. Okay, if you want to look at it this way, headless Chrome is a very expensive way of interfacing my webcam with the Twilio video streaming setup. And in fact, I did spend some time looking for a different way of doing it, but because Twilio is a consumer product, they support 3 different options, and they are JavaScript, iOS, and Android. So given the choice, I chose JavaScript.
Okay, and if you want, could you do it differently? For example, if you used something like wget from the shell and try to run the JavaScript part on Node or something like, would that also work? So it sounds like what you're doing is you're maintaining the connection with the browser and you need sort of an environment to run JavaScript in. So these other things would also work logically, right? Or no?
I don't think so. One of the important things with Twilio is, just like Discord, it gives you a direct socket connection between my browser and what's happening somewhere else. And that is supported by the browser, but not, you know, supported by wget. So in order to have this persistent connection and have the reconnection and detecting when it doesn't work and supporting of the connection to the webcam with a particular format, all of these things, you know, were built into browsers actually not too long ago. So I need this functionality. I can imagine somebody writing a short piece of code, not too long, which provides it otherwise. But this is what I found, and it works, so I'm using it. And as a bonus, I get other services like tracking, I get recording. In other words, I can record the video, which I have, of sessions of the rover, and it doesn't take up any bandwidth or hardware or memory on the rover. That's very useful. So I'm happy.
So if So it's like somebody who's viewing the webcam from a browser is directly having a socket connection to the rover. Is that
You can do it that way.
okay?
That's a peer-to-peer connection. Does exactly what you said. In other words, in the peer-to-peer connection, Twilio was used in order to do the discovery, so the different clients know who they are and where to connect to. But I'm using the, as an alternative, the server-based, where the video goes to some central video distribution network. So when I did the demo, I did it using the central one. Because having 6 people connected would kill the rover. It would have to handle 6 video streams simultaneously. And second, because I wanted to record it. And while I do have a local recording functionality, or the possibility to add a recording program running on my computer and acting as another client, that just adds more load onto the rover. Okay, so I'll say it again. It's exactly like having a video conference we're having now, except the video is only going one way. And if Zoom would have had at that time the right kind of tool, I would have used Zoom instead of Twilio.
So Zoom doesn't have any API to stream.
Not, they have something going on.
Okay.
They have a tool set. They want you to develop stuff. But Twilio seemed much more directed at people like me. But I'm sure that tomorrow we might swap it for Zoom and nobody will be the wiser. Twitter. So Twitter, Venkatesh told us and explained how to use it. But here we're talking about using it by machine. So gives you really public access. Anybody can see what you're doing. Anybody can interact with you. And because it's widespread, anybody really means everybody. So while I agree that Discord is also social media, it doesn't compare to Twitter in any way. Twitter supports media in a very nice way, which means if you post images or video, they work. Twitter supports two-way conversations. In other words, you can talk to my rover, and my rover will talk back to you. Right now, of course, the rover is not listening to anybody, but it's baked in. It also abstracts away the rover. If you remember, one of the goals is portability. In order to get portability, the details of the rover should not matter. So Twitter is even more abstract than Discord, and definitely more abstract than real-time control with video feedback. You send a message to the rover, you have no way of knowing where the rover is, what it's doing. The rover sends you a message back. Maybe it's human, maybe it's automated. Two important pointers for people who might want to use Twitter. The first one is, it's not on consecutive tweets, but when you send out a message, Twitter checks it compared to your previous messages. And if the text is the same, even if the image is different, it won't send it out. So if you give commands and the rover says, okay, and you give another command and the rover says, okay, the second one won't go out. So the actual, I'm still working on defining the actual conversational interface in such a way that it'll be easy both for people sending messages and for the rover answering the messages not to repeat themselves. And the other, yeah, please.
Yeah, the Twitter bot you have made, it's just saying that I'm online or something. It has been doing the same thing, I think. I've
Oh,
seen the same tweet, no?
it says I'm online,
Yeah.
and it also gives you a date. I
Okay.
mean, the text is not the same.
Yeah.
But if you tell it move forward, and then a minute later try to tell it move forward again, it might not get your command. And when the bot says I moved forward and here's a picture showing the results, and then again I moved forward, here's a picture showing the results, it's not going to send that out. So it's easy for the bot to add, I think Venkatesh suggested, some random letters at the end, so the text would be different. But I have to find a way to make it convenient for the person giving the command to send a different command each time.
Like, how about you? Like, you are also supposed to give an ID or something.
Yeah,
And
but you
yeah.
can't. So what you're saying is that have a message ID.
Yes, like you could, like it's like a ticketing service, right? So if I'm asking, what are you doing now? And then the rover replies, okay, I'm doing this, and this is your ID. Or if it's suppose somebody says, okay, give the do this image processing and send me the results, this is your ID. And then like somebody could query, okay, what's the status of this ID?
Yeah, but I'm wondering if you would be willing to type in that ID each time.
No, like once I have gotten an ID, then I could just type in a number while tweeting.
But you have to use a different ID each time you tweet. That's a twiggle.
Is this bot of yours on GitHub?
Right now, the parts that talk back are not written yet. What I've been doing is I've been checking. I've been writing different things, and I've been checking, and things have not been working. Okay. So right now, the bot has a setting where every time you do a command, it sends a Twitter message. Perhaps I'll show you. You'll see what I mean. So if you see here, this is in the middle of VAG. Those of you who were in the presentation remember that the VAG command tells the robot to move, run action group. So here, it's in a mode called make clip, meaning record a video. It runs a bash shell, which will make a video of whatever the rover is doing. Then it runs the VAG command, which actually tells the rover what to do. Okay, with arguments. Okay, now if the flag tweet outcome is on, meaning it's set up so that you give a tweet when you're done, we take a picture, okay, of wherever you are, and then we run a program called TweetThis, which sends a picture and says, I'm sending you this picture in response to this command. Okay, so I have the computer's talking part. I don't have the computer's listening part. I was just in the middle of testing two different ways of doing it. One way is polling. You know, once a minute, you see it say, did anybody send me something? And the other way is also on Twitter, you can connect to a live stream and just get Twitter like a fire hose coming into your computer. And just not written yet. Okay, so if you're interested, just so you get a feeling about how not complicated tweeting a picture is. Okay, this is a function which a Python program which sends a tweet. So here we have the part where we read our environmental information. There's two ways of authenticating on Twitter. I'm using the older one where you have 4 different keys. I get the name of the rover from the operating system. I connect to Twitter. And now it gets really complicated. If you have only one argument, so here's a function. You post the name of the rover and then the text which was sent to the program in the command line. And if there's a second parameter, then it's always a media file. So you tell him post the media. That's it. Okay, so this is really just glue between different ready-made libraries which do all the work. So I showed you that I have in the rover, when it gets a command, it runs a Python program which actually does a command, and then it runs another Python program which gets a picture, and then it runs another Python program which sends a tweet. The Python program which sends a tweet simply calls a command of sends a tweet, which is baked into the library. And if this were Telegram, it would look exactly the same. Any questions about this?
Yeah, I would
If
like
you
to
had
have
two
a.
rovers using this at the same time, would they be in some sort of racing conflict or something, like they both tweet and listen at the same time, Twitter API gets overloaded, that kind of thing?
Okay, right now, what I've been doing has been using the same Twitter handle for all of the rovers. In other words, if you think of my rover and Eric's rover, we're both using the same codes for here. Obviously, it doesn't have to be that way. Irrespective, I'd like to point out this part. Every tweet that this rover sends out starts with the name in here. This is formatting for my name, okay? So even if two rovers are using all of the same codes, they are still identifying themselves differently using a hashtag. So mine would be WWG and Eric's would be AFB. When you give a command, you're going to be required to give the name of the rover. So both multiple 20 rovers can be listening. And the way it works is they say, each rover says, give me all of the tweets on my homepage since a certain ID. That doesn't use them up. It just gives you those tweets. And then you would look through them and see which one have my call sign and only respond to them. Now, a different rover can carry out exactly the same command they would get the same, let's say, last 20 tweets, and they would choose a different one to respond to. And each rover will be responsible for keeping track of the last tweet that it responded to. So there wouldn't be any clash even if you had multiple rovers running. Yes, Anuraj?
Like I would like to have a look at this script, Python script. So
Waiting for you on GitHub.
okay, so it's on the Yak rover repos, right?
Yeah, that's what I said before. There's two repositories. One is called IMZ1, and the other one is called Rover Twitter.
What's the Yak collective user?
The
Yeah, there we
Yak
go. I see.
Collective. We're very sneaky. Okay. Another tool is Google Drive. I was just talking yesterday with Eric about collecting data, image data, every second. Doesn't sound like a lot, but the rover can run for up to an hour, and that builds up quickly. And while I do have a half terabyte disk, we don't really want the data to stay in the rover. We want to analyze it and apply deep learning or whatever elsewhere. So the question was, what is the best way to get the data off the rover? Obviously, we can use manual tools, but Google Drive can connect, and there's a nice Go-based program which allows me to push or pull files onto Google Drive. In other words, instead of synchronizing my Google Drive to my rover, which will obviously kill the rover both with respect to storage and bandwidth and CPU, I can select which files I want to send up and which files I want to pull down. An alternative is to use something like AWS or Azure and simply upload files for web storage and download them. I like Google Drive because it has a file system. But I'm assuming that as it becomes more automated, we'll move to some other cloud service. Especially if we decide to use one of these cloud services to do the processing of the data for learning and things like that. So there's tools that cost money. I found a free tool, but like I said, it wasn't so trivial to install it, but a little bit of help from the people on the message board, and we got there. Okay, most of this we've already talked about, actual software architecture. So we have the Discord bot, that's an IMZ1 file. We have commands in separate files. Right now, they're written in Python. They could be written in C++ or some other language. We have a command that tweets. We have, or not yet, but will, a separate program which listens to tweets, and in response to tweets, it will run commands. We have a video streamer. And one last element, which I didn't say before, Twilio requires a server to provide a token for access, I wrote my own server. It's about 3 lines long, which serves a token. Okay, so I do have one server, which when you connect to it, you give it your name, and it gives you back a token, which gives you permission to access the video room. It could also run on the rover, but I didn't want to go there. I don't know if any of you are familiar with Python anywhere. Python Anywhere is a service run by some people in the UK, which gives you a virtual Python computer.
Is it free now?
It's free. They have a free level and they have a paid level. I use both. For this, I'm using the free level, but I have other tools that I use where I use the paid level. They give you a Flask, it's called a server that allows you to very quickly build web applications. And this is a web application. Other people would build a Docker and put it on, AWS. Not important. Okay, so any questions until now? Till now was about actual toolchain. Okay, so there's also a conceptual architecture. And this is really a lot of a work in progress. So the first issue is levels of automation. Now, when I was just starting, I remember we got a handbook of industrial engineering, and they had a chapter about levels of automation. And they had like 12 different levels of automation. The lowest level is basically do exactly what I tell you. Move servo 5 degrees, and so on. And the highest level is when the machine does whatever it wants, and it doesn't even tell you about it, and you just try to figure out afterwards what the machine did. So one of the things that we need to go up in, okay, we're starting at the lowest level, but we're going up as the development proceeds, is at the beginning we tell the rover exactly what to do. Then we have commands. At some point we get to the level, and that's what we're working on, Eric and I. The rover should do what it wants, and it should tell me about it while it's happening. And then the next level, and that's mainly for debugging, there's no safety issue. And the next level is, let me, the user, figure out after the fact what the rover did or didn't do. The rover is autonomous. Okay, if you have teenage kids, which I have a few, that's the level of autonomy that you have. They do something, and maybe you'll find out about it, and maybe you'll be able to figure out what they did. So these really define the abstraction levels that we're thinking about, and they should match the architecture. Okay, the architecture of the robot matches these levels. So for the man and the machine, why is the man? The man or woman, of course, so man is, a general term, has to figure out what type of control they want to exert. More interesting, though, is if you remember, the goal was that we have a transition of different components of the system from manual to semi-automatic to automatic. So we want to define the commands and the level of automation in such a way that at the beginning we give the command and later a computer gives the command. The type of interaction we want to provide to the human to be similar to the type of interaction that we want to provide to a machine which does interaction. Imagine, if you want, that we have an AI program which is monitoring the rover and gives it advice. So I'm not looking at any type of AI component that does that. I'm looking at one that can give the same type of interaction and the same type of advice that a human would. Which means that right now, I need to define what the human can do in a way which I hope an AI will be able to do. So here's a few examples at the bottom. Right now we have a command forward 30, which means run the move forward action group 30 times and you move forward. Camera pin, that tells you move around. Attend. So that's really an idea. Venkatesh said that one of the commands he'd like to see is telling the robot to attend to a certain thing that's in the image. So you can imagine a command attend x2, where x2 is a coordinate. And now the rover attends to it in some way, and the rover decides what attending means, but we give it a command to attend. And then you can imagine a command like explore. We tell the robot, go explore. And we want to be able to interact with the exploration or modulate the exploration. Let's say we can watch the exploration and see that the rover is being inefficient. The rover is always looking at the ground instead of at the flowers. We want to be able to modulate what the rover is doing. So I don't yet know what it is, but what I can say is that the type of command and interaction that we're going to allow through this interface that I showed you is going to be selected according to what we think we can do with an automated component. So tune back in a few months. Okay. I want to port it. Okay, it's nice that I say that it can be ported. And I think you've noticed that I haven't talked at all or shown you anything that has to do with my particular rover. Okay, which, by the way, okay, so
What do you mean by port to a different rover?
I mean that if you have a rover which has a Linux board and a camera, I want to show that exactly the software that I have works on your rover. And that will probably mean changing the software a little bit because of all sorts of problems I didn't anticipate. But that's what I mean.
Like I don't have the rover, but I have the Linux computer and ESP32 cam. So basically, I would be using those on the rover when the mechanical parts are done.
Yeah. We'd be able to port it. We wouldn't be able to test the movement.
Yeah.
But you could pretend to do something and tweet about it. But yeah, that's what I'm looking for. I'd prefer it if we had an actual rover. Okay.
Yeah.
But for example, be interesting to put it on a Beagle board, which is not a Raspberry Pi.
Like Beyond has a camera and then it's running some OS inside, but it has a Python API for the drone.
Yeah, yeah. I don't know if
Yeah.
it has enough power beyond,
So like,
but I don't know.
so it could be run via the rover computer, right? It could be relayed.
Yeah, but it's not built for that. The way this is built, it assumes a consolidated architecture. So it would want to run on beyond.
Okay.
Okay, in a ideal world, we'd have it running twice, once on infinity and once on beyond. To those who don't know, Anuraj's system is called infinity and beyond, and infinity is a ground component and beyond is a flying component. So yes, all of the architecture I showed you doesn't deal with integration between different parts of the rover system. Instead, they deal with how does that rover talk to the world. So FBeyond has Wi-Fi. It's invisible to me if the Wi-Fi is relayed through some other tool. But I don't know if Beyond has enough CPU power, memory to run these things, but I'd like to try.
Yeah, I'm willing to give it a shot on the BeagleBone Blue. I think that has enough power to run this, and it's I think comparable in power to the Raspberry Pi. And what I'll end up having is sort of a half-assed rover within a month, which will have a camera and a couple of motors running. It may not actually move, but the motors will turn on and off, hopefully. And for the camera, by the way, I have an potentially interesting idea. I was thinking of using this little USB microscope, because the rover is moving so slowly and there's nothing much of interest to see in my apartment. It can look closely at the carpet and look for, like crumbs I've dropped and like dead bugs and stuff. So my plan is actually to try and attach this USB microscope as my camera, and that might make an interesting rover. But yeah, so I'll sign up to at least attempt this in about a month.
Okay, thank you. The second thing that's being planned is third-party remote services. One of the connections to the internet is in order to get services from the internet. So we need to define what these services are. And one possibility is some type of navigation function. And another one is another rover. So obviously, if it's infinity and beyond, we know what they want to talk about. But if it's a different pair of rovers, I don't know yet. From perspective of everything I showed today, the question is, what does the interface look like and how do they talk to each other? I need to actually build a useful abstraction set. It's not built yet. And I'm just reminding that I showed a very particular type of interface, but there are other possible interfaces. For example, eye tracking, EEG, GUI. I showed you text-based with video as feedback. There's the issue of, I said, we plan to throw one away. Well, the way you throw it away is when somebody comes and says it doesn't run on Beyond because it uses too much CPU, punch it. Okay, so when you optimize execution architecture, you probably replace parts, consolidate, and so on. The whole issue for collaboration between rovers, and I mentioned before, AI modularity. You have different AI modules doing different things. What is needed? And again, I'm not talking about the AI itself. I'm talking about defining a simple abstraction for these things, which is powerful enough to be useful, and that's it. Not the best there is.
So one suggestion I have for a very sort of low marginal effort to do collaboration between rovers is to use Twitter itself, since Twitter is already a sort of shared messaging bus of sorts with like the names of each rover in each tweet. So WWG can simply tweet at, ABF or AFB and say, AFB send me photo, and then that's flowing across Twitter. It's public, working in public. The rovers are working in public. So I think that sounds like something you can do right now, right? Pretty much.
Yes, I can do it right now. There's two questions. Question number one, actually, there's one question, but two constraints. The question is, what is the format of what I'm going to send on Twitter need to look like so that it'll be useful for collaboration? And the issues are the time delay and the rate delay. Okay, when you use Twitter, you have a limit on how many tweets you're allowed to send every minute. For human, it's not a problem, but two computers talking to each other, I obviously can't use a real-time protocol. So absolutely, I can send a picture, and Eric's rover has a powerful image processor, and it can send me back object detection of that picture. You have to think a little bit what the format's going to look like, but yeah, it's definitely a possibility. In fact, maybe that's the first possibility to do. Eric, what do you think? I tweet you an image, you send me the objects.
Yes, and it's something that I reported actually on the weekly report. Is that so with the org that we presented a couple of weeks ago, so we can get the image and we can get also the metadata. So for example, object detection, we can get the bounding boxes and so on, and we can send all that. But currently, and it's what is written in the report, is that to do that, we need to use their specific API, okay? That doesn't use the video for Linux loopback, video for Linux at all, okay? If right now it's configured on using video for Linux, and then we just get the video feed so that it can be connected to Twilio. Okay, so right now it's I haven't found a way to use both basically. Okay, I do have an idea, but so to be quicker, it's possible. Okay, I can provide the metadata as text or as an object that is directly usable inside Python or C++, let's say. Just a little bit work on the configuration to be able to do that soon.
So that could be an interesting first attempt. I have images, I want to identify the objects. My rover is not capable of doing that. Eric's rover is. I just ask for help.
But that would require a Twitter handle for each rover, right?
No. When I send a tweet, it appears in my home stream.
Okay.
You can read it. But I can also give, there's nothing stopping me from giving a separate handle to each rover. It's just annoying because each time you want to have a computerized handle, you have to ask for a developer's license, which they give you, okay? But you have to fill out a form, and it takes, 24, 48 hours. And if I want it to be easy to port it to people of this group, that is annoying.
I think there's actually a lot of advantages to having them all use the same Twitter handle, because now you can do a lot of interesting collective experiments. Like you could have a new hashtag saying spiders. So that means 6 of the rovers, only 2 are spiders. So it would say something like spiders send photo, and that would be like you 2 rovers would send photos. And then you could ask something like wheeled robots send photos, and that would be a different subset. And you can have different abstractions. You can define like logical rovers where combinations of like components on different rovers. I remember you talked about this when we did the kickoff meeting, where the logical rover is defined as like different functional capabilities on completely different physical rovers, and you could work with that. So all that, I think, would be interesting experiments to run under a unified Twitter handle.
Yeah, but right now there's only two rovers tweeting, so we don't have the need to go beyond one. Let's see how it works. Okay, any other questions, suggestions?
For anybody watching this later on YouTube, where can they find these slides?
I put a link, a public shared link on Discord. I guess we'll put it on in YouTube with it.